Welcome again to the topic homologous series. In the video before, we were able to see introduction to organic compounds, classification of organic compounds, ways of representing organic compound. We want to look into homologous series. What do we mean by homologous series? They mean families of organic compounds. We have many families of organic compounds, and one of it is alkane. Alkene, alkyne, alkanol, alkanal, alkanone, alkanoic acid, amine, amide. Then we also have ether. Then we also have ether, ester, etc. So we have so many families of organic compounds. Now there's what we call functional groups. What are functional groups? They are atoms or group of atoms that help us to determine the families of organic compounds. Such as for alkane, when you see single bond all through, it means it's from alkane. This double bond, this triple bond, this have OH, this have CHO, this have COR. Then this have COOH. These have amine. These have amide. Then this is alkoxy-alkane. We call it alkoxy-alkane. Then this is ester. Now, we discussed alkane, alkyne in the video before this. Want to see briefly what we can learn from all these other families of organic compounds. Once this, for instance, this, where arrow can be anything, such as alkyl group, where arrow is alkyl group. Alkyl group means alkane that have lost one hydrogen atom. So if you have CH4, it's methane. If you lost one hydrogen atom, you have methane, a methyl. So when you have this, we call it methamine. Then this methamine, when you oxidize it, it will give you amide. So it will give you methanamide. So, oxidation of amine groups gives you amide. Note that by oxidation method or process. Then, now we discuss alkane. We say it's saturated. Alkane and alkyne, they are unsaturated because they have double bond, triple bond. And this double bond, one is sigma bond, the other one is pi bond. Here, two pi bond and one sigma bond. So because it has pi bonds, that pi bond is weak. It can easily be broken down. So once it's broken down in reactions, it makes this to go into reaction easily. That is why this two goes into addition reaction easily. And alkane is noted to decolorize bromine water. Why? Because when it reacts with bromine water, the brownish color of bromine water will be decolorized. So it has the ability to decolorize bromine. That is differential test for alkane and alkyne. Alkane, only substitution, combustion, chlorination reaction that it can undergo. So it doesn't undergo addition reaction like alkane and alkyne. Now for alkanol, alkanol is broadly divided into three. The primary alkanol, secondary and tertiary. When do we we say that an alkanol is primary? It's when it has one alkyl group attached to the central carbon atom. This is called primary. Then this is called secondary, when two alkyl group is attached here. Then this is called tertiary, when three alkyl group is attached here. Now, it is noted that when this primary alkanol oxidizes in the presence of a strong oxidizing agent such as potassium tetraoxomanganate 7. So once this oxidation of this by KMnO4 will be giving you alkanal. Why this is alkanal drawn this way? Why oxidation of this will be giving us, oxidation of secondary alkanol will be giving us alkanone. Then this tertiary alkanol cannot be oxidized. Then this primary alkanol, as it oxidizes to alkanal, further oxidation will give us alkanoic acid. Okay? Note that this alkane can form alkanol. When you oxidize alkane, when you heat alkane in the presence of conc H2SO4 at temperature of 170 degrees Celsius, it gives us alkanol. Note that. So, once this is heated in the presence of concentrated H2SO4, that is sulfuric acid, and in the presence of temperature of 170 degrees, it gives us alkanol. Okay? Note that when alkanol reacts with alkanal, it gives us, when alkanol reacts with alkanoic acid, please. This alkanol reacting with alkanoic acid, it will give us ester. Another name for ester is called alkyl alkanoate. Another name for ester is called alkanoate. So, confirmatory test for this ester is that once it's produced, it has a fruity smell. So when you have a substance or a compound already produced and it has a fruity smell, you can suspect ester. Then check whether it's alkanol and alkanoic acid that react. It will give us this. That is RCOOR prime. This is alkyl alkanoate. Okay? Then for ether is written this way. Where you name this first, that is why we call it alkoxy alkane. Alkoxy alkane. So you name this first, this methyl group, you name it first before you name the whole. So alkoxy alkane. If the methyl group, if this alkyl group here is methyl, you call it methoxy alkane. If it is ethyl, you call it ethoxy alkane. That is how you name it. So this is just summary of what happens in homologous series and their functional groups. Okay? See the next video so that you see how you can name a given compound, especially alkane, alkene, alkyne. How can you name it? See the next video. Don't forget to click subscribe and like as you enjoy this video.